Welcome to another of our revision videos. This video is brought to you by SRCB 6th Form Geography Department. This video is ideally suited to the EDUCAS specification, which is the linear specification. First of all, thinking about glaciers, just recapping the last video, what we've got to understand is that glaciers are flowing streams of ice. They have their zones of accumulation and ablation. The movement and the processes related to a glacier are governed by the balance of snowfall, ice and ablation. Glaciers retreat by melting back, not by retracting, and glaciers produce distinctive landforms. The distinctive landforms are going to be what we focus on today. What we've got to understand is that glaciers can, although they range in size, are all subject to pretty similar processes. One process which occurs is the idea of abrasion occurring. Abrasion occurs when material the glacier is carrying rubs away at the valley floor and sides. It can be likened to the effect of sandpaper or a giant file. The coarser material may leave scratches on the rock known as striations. The finer debris often smooths and polishes rock surfaces. The debris involved in abrasion is often worn down by the process into a very fine material known as rock flour. Another process which occurs is the process of plucking. Plucking involves a glacier freezing onto and into rock outcrops. As the ice moves forward, it pulls away masses of rock. Plucking is mainly found at the base of the glacier, where pressure and friction often result in the melting of ice. It is also marked in well-jointed rocks and in those where the surface has been weakened by freeze-thaw action, known as frost shattering. Plucking often leaves a very jagged landscape. Two other processes which are important are freeze-thaw and nevation. Freeze-thaw or frost shattering occurs in areas where temperatures rise during the day but drop during the night, or for a substantial part of winter. Water which enters cracks freezes overnight. The cracks expand as ice occupies more space than water, roughly 10% more, and therefore exerts pressure on the crack. As the process continues, the crack widens and eventually pieces of rock break off. If this occurs on steep slopes, it can lead to a collection of material at the base known as scree. In a glacial valley, much of this material falls from the valley side onto the edges of the glacier and sometimes finds its way to the base of the glacier via numerous crevasses. So thinking about landforms, they can vary in shape and size, but what we've got to understand is that regardless of the glacier, the processes are pretty much the same. When we consider the advance and retreat of a glacier, we've got to remember that material is going to be transported in three ways. One way in which material is transported is supraglacial, which is on top of the glacier. This will often be in the form of rockfall. Another type of glacial movement is on-glacial movement. This is where material is moved in the body of the glacier itself. So for example, material that has fallen down crevasses, material that has been abraded from the side of the glacier. Finally, we have subglacial movement. Subglacial movement or subglacial transportation is the concept that material is moved underneath the glacier, so often this might occur in the form of a meltwater channel. Mountain glaciers lead to a number of landscapes, and you can see three different diagrams. Three different diagrams that you can see show the area in its pre-glacial, glacial maximum stage and post-glacial stage. In the pre-glacial landscape, you can see that very little, if any, of the landforms exist. However, during the glacial maximum, so the point at which the glacier is extended to its largest point, you can see a number of landforms and features developing. So for example, you can see denoted by the C, a cirque, evidence of lateral and medial moraines, and evidence of terminal moraines. After the glacier has retreated, you can see a further landform, the concept of a hanging valley, has developed. Glacial environments can occur all over the world. An example of a glacial valley is in Yosemite in California. Starting to think about cirques. Cirques are one landform, also known as a corrie, which are very, very important to explaining other glacial landforms. A corrie is an armchair-shaped hollow with a steep back wall and an over-deepened basin with a rock lake. It sometimes will contain a small lake, sometimes known as a tarn. In relation to the British Isles, which is important for you, corries are mainly found on the north, northeast and east facing slopes where there is reduced insulation, allowing more accumulation to occur. If corries develop in a highland region jointly, they may actually produce other landforms due to being back to back. In terms of a corrie and how it develops, the first stage is that fresh snow occurs in a hollow. Once that fresh snow has been compacted, the processes of frost shattering will occur above the glacier and plucking underneath it. There will then be scouring by the ice at the bottom and rotational flow occurring. That will therefore erode what is known as the back wall, and it will then eventually create the corrie as we see it today. An example you can see is the example of cirques in Colorado. So you can see going around the outside, these are the armchair shaped hollows. In addition, you can see other landforms existing. So here you can see the existence of an arête. The perfect example of a cirque is what has often been phrased the mother of all cirques. This is shown at Mount Everest. So the cirque you can see is shown here. You can then see evidence of the arête running along here, and finally the pyramidal peaks. Glaciated landscapes can occur all around the world. This is an example of the Sierra Nevada. We realistically have to make the assumption of what areas had looked like before glaciation. The reason for this is the time periods over which glaciation occurs. Not all glaciers that you see, you will be able to see the mountainside. An example of where that may not be the case is Antarctica, where we have a full ice sheet. Another landform which is important, this time a depositional landform, is the concept of moraine. Moraine is material which is deposited by the glacier during and after glaciation. So as you can see, located here are mounds which have been deposited by the glacier. Similarly, going back to this photo, you can see deposition. Moraines are very, very important landforms and very easy to describe. Moraines can occur in a number of different locations. So just taking you back to this slide here, you can see that the moraines can form in the location of the terminal moraine. So this is the furthest point that the glacier reaches. We have the lateral moraine, which is formed around the outside of the glacial valley. This will often be created by material eroded from the side of the glacier. If two smaller glaciers, so Glacier 1 and Glacier 2, join together, you will have the formation of a medial moraine. Another type of moraine that we have, not that is on this diagram, is a recessional moraine. So this would occur when the glacier is retreating, most likely due to climate change. If, however, there was an increased snowfall during a number of years, you might have what's known as a push moraine, which would actually push material forward back towards the point of the terminal moraine.